Can you build muscle on a low-carb or keto diet? Most people think carbs grow muscle because they spike insulin, but insulin doesn't actually build muscle, it just stops it from breaking down. The real muscle builders? That's protein and amino acids, especially ones like leucine found in foods like meats, eggs, and dairy. These switch on your body's muscle building process, even when carbs are low. And then there's ketones, your body's backup fuel when carbs are low. Ketones don't just help burn fat, they also protect your muscles by giving your brain and body another fuel source. Research shows ketones reduce muscle loss during stress, help your mitochondria work better, and even support recovery after workouts. So yes, you can build and keep muscle on keto. This is lecture 116 of the Metabolic Classroom. Looking to improve your own metabolic health? Visit insuliniq.com for courses, coaching, consultations, and a 10-day free community membership trial. To dive deep into the science behind metabolic health, become an insider at benbikman.com, where you'll enjoy my exclusive content, ad-free podcasts, live stream Q&A access, and more. Hello and welcome to the Metabolic Classroom. I'm Ben Bikman, a biomedical scientist and professor of cell biology. In today's mini lecture, we're discussing a topic that's generated a lot of questions from my students, colleagues, and many online communities. The question is, can you build muscle on a ketogenic diet? For decades, the fitness world has been dominated by the idea that carbs and the insulin spike they trigger are essential for muscle growth. But as research evolves, we're seeing that's not the full picture. In fact, a well-formulated ketogenic approach with the emphasis on fats and proteins and lower in carbs could be more than adequate for muscle preservation and even gains. And this, as you'll see, is going to be thanks largely to the role of amino acids and even some unexpected effects of ketones directly. Now, as we go through the mini lecture, I'm going to be the penultimate professor and start with some of the basics, including the misunderstood role of insulin when it comes to muscle building. And then we'll discuss how amino acids really actually explain what some people think what insulin might be doing, both from a building and a protective perspective. And then from there, we'll examine how beta-hydroxybutyrate, the main ketone, defends muscle and acts as a fuel switch, if you will, for the brain, helping preserve what's in the muscle already with its proteins. And I'll share some findings from my own lab, as well as work from other groups that look at the effects of ketones in a variety of situations, including with aging and even disuse or bed rest. But in the process, we'll debunk some myths. And then even talk a little bit about exogenous ketones, where if you feel like you need a bit of an edge, that might be a way to do it. Now, whether you're an athlete or just someone who tries to stay fit, we all want more muscle. At a minimum, we want to keep our muscle. It is one of the strongest predictors of longevity. We don't want muscle going anywhere. So any advantage we can get, we should be interested in leveraging. And as you'll see, ketones, in fact, may provide some advantage. Okay, let's get started. Firstly, I mentioned starting with insulin. Boy, what a place for a guy like me to start. I can never get too far from discussing insulin. And when I have the opportunity to discuss it, I'm going to do so as quickly as I can or as early as I can. To understand muscle building on a low-carb diet, we have to first really understand insulin's role, because this is where so much of the misconception begins. Insulin is a master metabolic hormone, and it does, in fact, have a very powerful influence on anabolic reactions. Remember, metabolism is the balancing of both catabolism and anabolism. Anabolism being the building up reactions and catabolism being the breaking down reactions. Well, insulin likes to build things up. But let's be precise. When it comes to muscle, insulin isn't anabolic per se, but more accurately, anti-catabolic. This is a topic and a point I have made abundantly in the past, citing direct cell and whole body human studies. And I'm not going to do that again here. You just have to take that for now as a statement of fact. Insulin prevents the breakdown. It inhibits proteolysis. It does not directly promote muscle protein synthesis. So it's not directly pushing the proteins in the muscle to form to result in bigger muscles. But once the protein is built, it's helping defend it from being broken down. If we were to look at the muscle as a construction site, proteolysis would be the demolition of the structure that the muscle protein synthesis built. It would be the laying down of bricks. So we have muscle protein synthesis where we're putting all the bricks together, building a wall, which is going to be part of a home. And then the destruction of it would be proteolysis. Insulin is, if you will, like a security guard who's monitoring the site to make sure that some ruffians don't come in and start destroying what has been built. So it keeps it in shape. Insulin keeps the muscle filled with its protein. It keeps the protein in the muscle. So when you do consume carbohydrates and blood glucose rises, which in turn prompts an insulin release, the signal from that insulin to muscles is going to be to hold on to what you have when it comes to protein. Now, I'm not talking about nutrients. There'd be other direct effects when it comes to glucose and lipid handling, but that's not the topic here. It's protein, which I don't consider, and I don't think should be considered like fats and carbs are. But studies do confirm this. Insulin infusion reduces protein breakdown by a lot, but it doesn't do anything to promote muscle protein synthesis on its own. Now, I deliberately emphasize that part, insulin on its own. What insulin can help with is when amino acids are elevated. But just to really put a fine point on that, even at super physiological levels, so when insulin goes beyond what you'd normally get, it still has a minimal, negligible, or no effect on muscle protein synthesis. It's supportive when it comes to protecting or defending the muscle, but its support role goes a little further because it will facilitate amino acid transport. So if amino acids are elevated, now insulin is doing something a little more meaningful. But even still, that does not suggest that the amino acids need insulin, and that's critical, or that the amino acids require an insulin bump for them to do their job, because amino acids are in fact the hero, and insulin in this story is a bit of a side player. Pains for me to put insulin in a corner, but someone's got to do it in this case. Now, this information is very important for people who adhere to ketogenic diets because, of course, a low carbohydrate diet is going to keep insulin levels at a more steady state. It's not going to be elevated, certainly not chronically, and you even won't have very frequent peaks. You're going to be avoiding all of that dynamic ups and downs, mostly ups, more than downs nowadays. But would that mean muscle loss? Well, not at all, because there are other factors that can more than compensate. So you would say, even in the most generous view, well, the lower insulin is going to result in a failure to defend the muscle. It's not that simple. And that leads us to amino acids. They're the true architects of the muscle. Coming back to that building construction site metaphor I mentioned a moment ago. When insulin is low, as in ketosis, amino acids will step up. They can directly stimulate muscle protein synthesis and also inhibit proteolysis in ways that not only mimic on the back end, but even surpass insulin's effects. Essential amino acids, especially the branched chain amino acids like leucine, isoleucine, and valine, are key. Leucine in particular activates the mTOR pathway, a master regulator of all cell growth, including muscle. mTOR senses nutrient availability and flips the switch for protein synthesis in muscle fibers. Studies on older adults show that supplementing with amino acids, especially those rich in leucine, increase basal levels of muscle protein synthesis and can increase lean mass even without high insulin. In fact, mentioning insulin, I should state that branched chain amino acids, when they get high enough, can have an insulinotropic effect, meaning they can stimulate a modest insulin release from the pancreas on their own. So even in the absence of eating carbs, a person who's eating a lot of branched chain amino acids is going to have some insulin effect. And I would say in this context, that's not a bad thing. That if you are consuming a lot of branched chain amino acids and you're getting some insulin release, that's a nice time to have an insulin release, because then those amino acids are going to be more directed into the muscle. And again, you don't need to do that by eating carbs. And further, as much as I just described the front end or the building up, amino acids do protect the back end. They suppress breakdown or the degradation of the muscle protein, much like insulin does. In resistance-trained individuals, high protein intake during low-carb periods maintains net protein balance, which is a proof positive, a sure sign that catabolism is being blocked. And so we do want to emphasize protein. I don't want to get ahead of myself and get into strategy here, but the general range that you hear of up to like 2 grams or so of protein per kilogram ideal body weight, that is one to really stick with for the most part. And of course, unapologetically, I state that you want to get that from animal sources more than attempting to get it from plant sources. But this is going to really load the system with essential amino acids, and it's going to make up for any lack of big insulin effect. One particular paper in women found that amino acid supplementation boosted IGF-1, the insulin-like growth factor, which is an incredibly strong signal for activating mTOR. So that just indicates further the anabolic power of dietary protein. So if insulin is low, rather than bemoan the potential that you're not fueling or building the muscle, have confidence that amino acids are more than making up for it. But the amino acids aren't alone. So let's now turn to the intended star of the show, which is ketones. This is the metabolite that gives the ketogenic diet its name, and they do have a pretty fascinating role in protecting muscle. By way of a brief primer on ketone metabolism, ketones are produced when the liver is burning a lot of fat. And the main ketones are acetoacetate, acetone, and then the primary one of all, beta-hydroxybutyrate. For far too long, of course, ketones have been considered, well, once upon a time, metabolic garbage. But even now, it's like we can't describe them without calling them a backup. In fact, I even mentioned that a moment ago, and that absolutely is not fair. Ketones are not a backup to glucose. And that term is usually derived from a mistaken view of what happens at the brain with its metabolism, where many people consider that the brain's primary fuel is glucose and it will only use ketones when it needs to. And that is demonstrably false. Let me say that again in a different way. That is not right. It has been shown that the moment ketones come in the blood, the brain is already using them, even if glucose is still abundant, and indeed, even if glucose is higher than ketones. That directly proves false the idea that the brain prefers glucose and that the ketone is a backup. If anything, it suggests that glucose is the backup and that the brain prefers ketones because, again, it will use the ketones even when the ketones are at a lower level. Now, this is important because if the brain prefers or at least readily uses ketones, that means the brain's demand for glucose goes down. That's important because if there is an incessant and dramatic need for the liver to produce a lot of glucose, even though most of that glucose via gluconeogenesis will be coming from lactate, if the need is sufficiently great, some of it will be coming from amino acids from the muscle. At the risk of opening up a whole tangent here, this is the difference between starvation and fasting. It's, do you have ketones? Do you have enough fat to burn? And indeed burn that into ketones, because then the brain will use the ketones and then the amino acids can stay in the muscle. But in the absence of ketones, the brain must get all of its energy from glucose, which will sooner than later require the body, to start mobilizing the carbons from the muscle protein, thus stripping the muscle. All right, so again, this is why people for decades have said that ketones are muscle sparing, because they spare the protein. It's like diverting a river. Ketones will redirect the brain's energy needs away from raiding the muscle. So in this sense, ketones really do defend the muscle by telling the brain, you are well fed, and you don't need so much glucose, and so leave those carbons in the muscle that could have the potential to become glucose. But the story doesn't start there in a kind of abstract way of just brain fuel use, because, and this is critical, BHB actually also has direct signaling effects at muscle. It not only enhances mitochondrial function and promotes mitochondrial fusion, and that's work from my own lab, by the way. In fact, allow me to elaborate because it's a little self-aggrandizing, if you will. We published a report finding that when muscle cells were fueled with beta-hydroxybutyrate, that it not only enhanced mitochondrial structure and integrity, but it resulted in greater ATP production, reduced oxidative stress. And when we challenged the muscle cells with some noxious stimuli to damage them, the muscle cells fueled with BHB were more resilient. They were stronger, more resistant to injury. Even further, in aging models, BHB can reverse sarcopenia. That is important because one of the best predictors for longevity is muscle mass. So anything that preserves muscle is a prudent strategy to live a long, healthy life, and ketones help. In fact, in one study with some aging rodents, when given ketones, they found that the muscle maintained more than 20% of its mass relative to the controls that were aging alongside them. And this was in multiple muscles of different fiber types. You might have heard of fast twitch or slow twitch. All of them maintained roughly 20% more of their mass. And the muscle fiber size was pretty stable across the groups, but it was actually, they found a favorable enhancement in muscle fiber type, making the muscle stronger and faster, as well as more mitochondrial biogenesis and reduced proteolysis. Incidentally, the mice also lived longer. Further, incidentally, in the female mice, the higher they bumped up the ketones, the greater were the improvements in spatial memory and even reducing anxiety. And they actually thought that was because there was a better effect at breaking down neurotoxins. So that's all tangential, but nevertheless part of the whole story. Now, there are instances where a person may lose muscle mass because of disuse. So even here, in atrophy models that have been studied, like bedrest simulation, BHB will preserve muscle size. For instance, one method of testing this is something called hind limb unloading. It's an experimental model used in mice where they will suspend one of the limbs. So basically a little kind of cart that the limb is up in. And so they're not using the limb. And muscle mass will often drop by almost 30% quite quickly through disuse. But when the animals were given beta-hydroxybutyrate, it prevented about 80% of that loss. So it maintained the muscle fiber size, including the diameter. And what they found was that the BHB was activating the mTOR pathway and suppressing some of the autophagy pathways. So it was helping the cellular signaling change, the cell biology of the muscle change in such a way that it had a greater balance towards anabolism rather than catabolism. And part of this is they found that BHB boosted glutamate, the amino acid glutamate, which can be used for protein synthesis, while reducing some of the markers of oxidative stress, which can damage, of course, muscle cells like it can any other. So this has some potentially very cool applications in humans when it comes to things like bed rest, like even post-surgery recovery or aging as physical activity starts to drop. One of the main concerns with low-carb diets is glycogen. Glycogen is the most immediately used fuel within the muscle. So this is when glucose is stored within the muscle. So it's muscle glycogen. And what do you think keto would do to that? If you're not eating carbs, how can you replenish your muscle glycogen? Well, that does not appear to be a problem at all. Some incredible work by Jeff Volek and his group. And when you talk anything about ketogenic diets, Jeff Volek is one of the godfathers of all of this. He found that keto adapted athletes not only maintain glycogen levels in their muscle similar to high carb eating athletes, and that was found to be because they just use a lot of fat and they spared the glucose. Even when the glucose was diminished, other work has shown that it gets replenished in the muscle extremely rapidly, even in the absence of eating a high carb diet as a follow-up. So even if you do deplete muscle glycogen in a ketogenic diet adapted athlete, and again, they preserve their glycogen better. You actually still restore it even without eating carbs. And that's just because the muscle is going to gobble up whatever glucose that the liver is making. And again, most of what the liver makes into glucose is coming from things like lactate and glycerol. It's an incredibly uncommon scenario for it to be using amino acids from muscle. Okay, now, so far, I've already been kind of debunking some myths. So let me address some of these directly right now for just a moment. So one of the myths would be that keto causes muscle wasting. The reality is that there are short-term studies in humans showing a transient reduction in fat-free mass, but the problem is those are all confounded by water loss. So as many people may know, when you adopt a low-carb or ketogenic diet, as insulin comes down, overall blood volume, because of a reduction in blood water or body water, will go down. And that will be reflected as a loss of fat-free mass. And so some, I would say perhaps a bit ignorant, researchers would say that that results in a reduction in muscle mass. You cannot say that. And indeed, the data don't support it. You could say that they have less body water, and that might be why their blood pressure came down so well. So anyway, even the transient studies, which may report a reduction in muscle mass, don't actually support it. In fact, meta-analysis work finds that a ketogenic diet not only does not result in a reduction in muscle mass, there's even some evidence to say it maintains it even while fat mass may be going down. Okay, now another myth. No insulin means no growth. Now, no insulin would mean no growth. If you wipe out insulin entirely, you're not going to maintain any amount of mass at all, fat or fat-free mass. But that's not what happens in a low-carb diet. Even the modest amount of insulin that is always present is sufficient to defend muscle protein to at least some degree. And remember, that is where insulin matters. It doesn't matter on the building side, it matters on the defense side, but a little goes a long way. And remember, there are redundant signals like amino acids that can step in. Even further, ketones, beta-hydroxybutyrate can step in. And then myth 3, independent of muscle mass, may just be a concern for general performance. That is not holding any water anymore. For endurance performance, the data are very clear that, in fact, it may be superior than in the absence of ketones. And then for power, the field starts to get a little leveled. And then back, maybe one final comment with regards to aging. There was a paper from UC Davis that looked at older animals and found that the ketones enhanced muscle size and strength. So even beyond performance with athletes, if we just looked at maintaining the performance of life with aging, evidence suggests that ketones can help. All right, now everything up until this point was me generally presenting the paradigm of a ketogenic diet, so a low-carb diet. But what if there is someone who does not want to adhere to the restrictions of a ketogenic diet, but still wants the benefits of ketones? After all, maybe they're thinking, well, I want the best of all of these worlds. I want the glucose, and I want the insulin, and I want the ketones. Well, that is where exogenous ketones could become very relevant, especially if it's the right kind. So I'm very much an advocate of just getting real ketones in the form of real beta-hydroxybutyrate. This can come in salt forms where it's bound to a cation like sodium or magnesium, etc. Or nowadays, you can also get it in this free acid form, which pure beta-hydroxybutyrate for much faster bumps in ketone levels in the blood. So salts are more affordable with a more modest effect on ketones, and BHB acid is more potent, but it is pricier. But both will work, and that's what I encourage people to look at. So when you're buying exogenous ketones, make sure you're actually getting a ketone, and in the form of beta-hydroxybutyrate. Okay, there are a couple papers I want to mention here as we near the end of the mini lecture. One was published in 2018, and they found that BHB had an effect on muscle metabolism in a state that would normally be very catabolic. So interestingly, they took human participants, and in this trial, they gave them an infusion of something called lipopolysaccharide, or LPS, to induce this systemic state of inflammation. When inflammation is up, one of the effects will be catabolism at the muscle, so stripping muscle. However, what they did here was it was a fascinating study. They gave, during 1 week of this inflammation scenario, they gave them BHB in a randomized order. Another time, they gave them free fatty acids matched to calories, because after all, beta-hydroxybutyrate does have a caloric value. So they put in other calories, non-ketone, or they gave them a saline placebo. And then they used these labeled amino acids to just determine exactly what's happening at the muscle. And the team found that the beta-hydroxybutyrate significantly slashed muscle protein breakdown by up to 25% compared to the other conditions. So a very strong net anti-catabolic effect that helps to preserve overall protein balance, keeping it in the muscle. A paper published the following year, 2019, looked at athletes, and they actually had the athletes deliberately overtraining, so a significant exercise-induced stress. And then they had them take ketones, they had them take glucose in a control situation, and then while going through this very rigorous punishing protocol. And they found that if they were given any kind of fuel, they were able to preserve some degree of muscle mass. But the ketone group went even further by blunting the symptoms of overreaching, like reduced stress markers. So the glucose group had much higher stress markers reflecting the stress. The ketone group had lower levels of stress markers, indicating a buffer or a protection. But they also had improved performance. They were able to continue to perform at 15% higher than the glucose group, even in the midst of this stress from the overtraining. This could be relevant, I think, in people who are not only undergoing very high volume training, but even those who may be needing to go through some weight reducing phases to try to meet a weight for a given event, maybe wrestling or boxing, that kind of thing. All right. That is the deep dive. That is the mini lecture in the metabolic classroom. Yes, muscle building on a ketogenic diet and with ketones is possible and maybe even optimal depending on the metabolic health and starting point of the individual. If you want any of the citations, remember, please consider going to benbikman.com and becoming an insider. Thanks for listening. Until next time, more knowledge, better health. Looking to improve your own metabolic health? Visit insuliniq.com for courses, coaching, consultations, and a 10-day free community membership trial. To dive deep into the science behind metabolic health, become an insider at benbikman.com, where you'll enjoy my exclusive content, ad-free podcasts, live stream Q&A access, and more.